Good evening, everyone. I am K.S. Narayan. I welcome you all on behalf of the IIT Alumni Center, Bengaluru, for this 53rd webinar. We have been conducting these webinars online since the onset of the pandemic first wave in April 2020. This has been a successful series, and in case you have missed it, you can find our previous webinars on our YouTube channel. So we are back from a brief vacation to hear about a very interesting topic, spoken language technologies for the under-resourced languages. So what is language? Human language is really distinct from anything else in the world. A question which is of interest to me is, what is it about human brains that allowed language to evolve in a way that it did not in other primates? So at some point, our brains became able to make our mouths produce vowels and consonant sounds, and we developed the capacity to invent words and name things around us. So wiki definition is a language consists of discrete bits with unlimited combination usable to express thoughts, intention, feeling, etc. That is digital, infinite, and intentional. So this understanding in language structure and development is really grown and needs especially to be applied for our under-resourced language of our country. So we have the expert in this topic, Professor Mahadev Prasanna, to tell more about this today. A brief introduction on Professor Prasanna. He, after his BTech and his MTech from NIT Surathkal, he did his PhD at IIT Madras. Currently, he is at the Department of Electrical Engineering in IIT Dharwad. He was earlier at IIT Guwahati. He has supervised many PhD students and research scholars on different issues related to spoken language technologies, which is published extensively, and is leading groups across India and abroad towards spoken language technology development. The current interest of his group is to develop spoken language technologies by exploiting the current trends in AI fueled by deep learning. One specific attempt is developing spoken language for tribal languages. Moderating the webinar is Professor Chandrasekhar Silamantula, who is a professor at the Department of Electrical Engineering at Indian Institute of Science, Bangalore. After his undergraduate in Osmania, he obtained his PhD in the EC department, IISc. He has contributed to a variety of research problems in the area of non-stationary signal modeling, auditory modeling, and speech audio compression. I found out that he's also interested in bio-inspired signal processing, auditory motivated speech audio processing, bioacoustic analysis of cricket sound, bird songs, elephant calls, and wonderful such sounds. Along with me, we also have Dr. Sushila Venkatraman of the IITACB in the panel, who will wrap up the session. So I will encourage the audience to really participate and engage in this discussion via the Q&A box, okay? Not the chat box, okay? The Q&A box. Okay? So over to you, Professor Prasanna.
Yeah. Shall I go ahead, Chandra?
Yes, please.
Thank you very much, Professor. Are my slides visible?
Yes.
Thank you, Professor Narayanan, for that introduction. At the outset, let me thank the organizers of this webinar from IIT Alumni Center, Bengaluru, for giving me this opportunity. In this webinar, on behalf of a multidisciplinary team under the aegis of AI Task Force of IIT Alumni Center, Bengaluru. We are attempting something which is to see that the benefits of artificial intelligence can be used to the society in the fastest manner possible. In our several brainstorming sessions in the AI task force, one of the identified direction was how about uh, leveraging the benefits of AI to develop and deploy spoken language technologies for the tribal languages of India. So in that process, the multidisciplinary teams were put from across India, coming from academia, industry, and NGOs and other organizations. And over the discussion in about a year or so, the framework and strategies that are evolving are not only limited to the tribal languages, but can be used for any other Indo-resourced language present in India and abroad. Of course, information is available in the public domain. There are several hundreds of tribal languages in India. The sequential approach for developing spoken language technologies is not feasible. We need to get a scalable framework to come up with strategies to develop spoken language technology. So that was the thought process behind setting up this multidisciplinary team and trying to work in that direction. Of course, when it comes to the language technologies for Indian languages, the government of India is supporting this research and development efforts for a long time. Specifically, the Ministry of Electronics and Information Technology, Government of India, and Department of Science and Technology, to name few ministries. Of course, under different schemes, it all started with technology development, Indian languages, to the latest National Language Translation Mission. This effort is specifically supported by the R&D in IT division of MeitY, Government of India, and the Technology Innovation Hub of IIT Bombay. The presentation is organized as follows. I will briefly introduce this fascinating field of spoken languages, which we are all witness to that, especially in India, since we are all growing up in a multilingual society. We enjoy that linguistic diversity. However, when we see the digital world, where we are all communicated through or connected through the digital world, the resource creation, knowledge availability is mostly in terms of some what we call high resourced languages. Just to give an example, English is a high resourced language. Where alternatively, if you consider most of the spoken languages in the world are under-resourced languages. However, as humans in society, we benefit from this linguistic diversity and also multilingual expertise that we have. Efforts are also required for the benefit of the society to make this digital world more inclusive in terms of developing language technologies for this as many as possible spoken languages. So in that direction, a lot of effort is going on worldwide. Thanks to the latest technological trends in artificial intelligence, now the time seems to be ripe where we are able to develop spoken language technologies with a much lower effort compared to what was happening a decade back. So in that direction, that part, this multidisciplinary team is exploiting to come up with the technologies that will be useful for the society. One of the important challenges that we will meet with when we want to develop language technologies for under-resourced language will be the digital language resource creation. If I go for high-resourced languages like English, there is already a lot of information available in the digital space, which can be easily organized and prepare a data set and then build the technology. Whereas when we go for the under-resourced languages, specifically tribal languages, this becomes a very important step. This is where the AI task force of IIT Alumni Center, Bangalore, put a lot of effort in bringing partners from different walks of life who came on board to help us in the creation of the digital resources, which I will be explaining later. That part I will share the experience. The interest for detailing out this is when we started this effort, we were also clueless because we are all coming from the bias of high resource or language. But when we go to the tribal community and try to see what resources are available, how to win their confidence, and how to collect the resources and organize them, it's a very hard task. And we realized that it may be true for any other tribal language which you want to work on. So accordingly, the effort that we have made as a multidisciplinary team, if it is documented, and this pipeline can be replicated to the other tribal languages also, because we have been contacted by many small research groups across India who are working in these tribal languages, and they are clueless in terms of how to go about for collecting data, organizing, and developing technology. And the next important part which will be presented is the effort towards development of the spoken language technologies for these tribal languages. One important decision we made as a part of AI task force was, suppose if I just take high resource languages as a reference and try to mimic that process for developing spoken language technologies for the tribal languages, that will be a long drawn battle. Instead of that, can I exploit the latest technological landscape that we have in terms of latest trends in artificial intelligence, the computing infrastructure we have in terms of GPUs and cloud, also the lot of rich digital resources available for the high resource languages, to use them and leverage them and then build technologies for the tribal languages. Of course, from a linguistic point of view, it looks awkward. However, from a technology development point of view, it seems to be working. And as a result, much less effort is needed if I want to build technologies for the tribal languages. And that framework can easily be replicated for any other tribal languages of India and the world. Then another point that we discussed was, it is one thing is about resources creation. Second thing is about technology modules development, spoken language technology development, modules development. And the next thing was, it is not first I will develop spoken language technologies like speech recognition, speech synthesis, machine translation, then evaluate their performance and compare with the high resource language. Once I achieve the performance to that level, then only I will worry about developing an application. We took a slightly different approach that whatever may be the level of technology performance of these modules, let us communicate with the tribal community or the organizations which are working with the tribal community and identify one or two applications and try to use these modules at whatever the level they are and see how we can come up with an application there. It may not work great in the beginning, but at least the community will come to know that, oh, these teams are trying to do something for this community. So we can get an inclusive participation from them. And so accordingly, that will help us to scale up these activities at a later point of time. So that effort also I will briefly mention on behalf of the committee. Then I'll summarize my presentation. Of course, especially in India, as I mentioned in the opening remark, we are truly in a linguistically diverse society. Multilingualism is there, but and this is true for the other parts of the world also. But more richness is there in Indian languages. However, as I mentioned, when I go to the digital world, it's mostly in terms of few languages. If you want to have an inclusive society, and we want to transfer the benefits that we derive from these high resource language in terms of the information and knowledge available in the digital world, it is best communicated to them in the language they know understand better. So that is where understanding this significance, United Nations declared 2019 as the International Year of Indigenous Languages. They also organized a conference, international conference in Paris in 2009 with a theme that on language technologies for all. That means to say, it's a big dream to ensure that can we develop language technologies for all the spoken languages of the world? Okay, essentially, we want to transfer the linguistic diversity and multilingual thing that is there in the human society to the digital world. So that is where, we will have a multilingual internet and language technologies for all these individual indigenous languages. Of course, the question comes is, why do you need language technologies for all these spoken languages? As I mentioned, any latest information in the world and the knowledge about the society are mostly available in the high resourced languages. So if that is the case, we are denying the opportunity for the community who know only indigenous language about what is happening elsewhere in the world. That is one side of the story. The other side is, as we know, each community will have their own local tradition and best practices in terms of health and well-being and the practices they do, which is available only in that indigenous language and only for that community. Suppose if we are able to intervene in terms of language technologies, we can preserve them and pass it on to the next generation. Of course, there is, when we discuss with linguistic community, they call about when people start using high resourced languages, the indigenous languages will be affected. The population to use those languages will dwindle. So with the help of this digital intervention, we will be able to preserve them, and also we can even enhance the population size to use those indigenous languages. Of course, the digital literacy and educational content in local languages can be made available. So these are some of the factors which motivate the community to work on developing the language technologies. Of course, this is there for a long time, but as will be explained later, now the effort required may be relatively lower compared to what was we were thinking when a decade back. Of course, roughly there are about over 7,000 spoken languages, and very few out of them, we can count in tens, who have some digital presence. And accordingly, majority of these languages are under-resourced languages. As a result of this, there is a digital divide between knowledge sharing between the high-resourced language and this under-resourced language. Of course, linguistic communities say they are working on endangered language community where the population size is dwindling, and as a result of that, the language, if you don't preserve them, it will die after some time. But what we are talking about here, in this case, in under-resourced language case, we are talking about digital extinction. The language may be there in the society, but there is no digital presence. But what is required now with so much happening on the digital world, we want to create their presence in the digital world so that we can provide content and services in their own language. And accordingly, we can equip these language users with the latest digital developments. Of course, I used this term high-resourced versus under-resourced. Of course, whenever I want to develop a language technology in general and spoken language technology in particular, we need a lot of resources like text corpora, speech database, lexical, syntactic, and semantic resources. And also, this database, one size will not fit for all. If I am developing a specific technology module, say I'm working on speech recognition, there is a specific way when we can collect the speech database. On the other hand, if I go for machine translation, there is another specific way I have to collect the resources. In that way, we also have to focus on task-specific resources. So when I consider, of course, depending on the resources available, there are terminologies used in the literature in all different ways. But from this presentation point of view, I will just limit myself into high resourced versus under resourced. When I go for high resourced, all these resources which I mentioned above are available in abundance, large quantities, whatever you require, and in the digital format, for example, English language. So you can have, when I am talking about using deep learning models for developing spoken language technologies, all these deep learning models are data hungry. So accordingly, they are talking about using several thousands of hours of speech data for building a reliable model whose performance is comparable to that of human level performance. And that has been demonstrated for some of these high resourced language like English. Alternatively, when I come for these under resourced languages, if not nil, there is a minimal digital presence. There is a lack of some or all of these resources when we want to build spoken language technologies for these under-resourced language. For example, one is our Soliga tribal language spoken in Chamarajanagar district of Karnataka, which is also one language which we are considered for effort. So if you see this, there is a contrast between the resources that are available for a high resourced language where majority of the communities are focusing. And there is on the other spectrum, we have this under-resourced language where looking at the requirements of large quantities, many groups are not paying attention for that, mainly because of the cost, time, and effort. And of course, so if I look for any private organization, commercial exploitation point of view, they don't see much market there. But so in this direction, as a part of a task force of IIT Alumni Center Bangalore, we identified that something we should intervene here, where how do we come up with strategies to deal with this limitation we have and develop spoken language technologies which can be used by this community. One of the important decisions that we made was it is better to sit on the shoulders of high resourced languages and leverage their capabilities and build spoken language technologies for these under-resourced language. The advantage there will be, I may be able to develop spoken language technologies which much lower digital resources created compared to what is available for high resourced languages. Thanks to the latest developments in artificial intelligence powered by deep learning, there are models which are data hungry, but we can train these models using the resources available from the high resourced language. Then you can fine tune or adapt them for spoken language technologies of under-resourced language, where I have collected only a small amount of data compared to the effort that is going in the high resourced language. Of course, we also have computing and cloud infrastructure. So this is the strategic decision that we made. We will not build technologies from the scratch. Alternatively, we'll come up with strategies where we can indeed exploit the publicly available digital resources of the high resourced languages and then build on top of them by adapting them or fine-tuning them so that quickly we can ramp up and develop and deploy some technologies. So this is one of the important strategy. So then that was once that strategy was done, how do we get when we consciously decided we'll work on the tribal languages, reaching to this community itself is an issue. It is not just going one day and collecting some data and coming. We need to have organizations who are working with this community for a long time. And through them, we can reach out to the community and convince them to be part of this digital language resources creation. So quickly we realized that we need a multidisciplinary team to come up with some feasible solution for this work, this effort. Of course, academic institutions are there, starting from IIT Dharwad, IIT Dharwad, IIT Hyderabad, and IIT Bhubaneswar, who can definitely, once they have the technical know-how in terms of what goes for the high resourced languages. Once they have digital resources, they will be able to develop technologies. But what is more important is how do you create the digital language resources at the first place? That is where, thanks to the intervention by IIT Alumni Center, A special mention to the Sampurna Swaraj Foundation, Dr. Shankar Prasad, sir, who came forward and put up the team from different organizations to ensure that we will start this process of reaching out to the community and get the resources from. Similarly, IT Alumni Center also reached out to an organization working in Orissa towards the educational content creation in local languages, what is called IIT Learning. They are doing a wonderful job in terms of creating educational content in the local language. They also came on board. Then Shiksha Anusandhan University from Bhubaneswar came on board. Then Bagalkot Engineering College came forward. These organizations are chosen depending on the geographical location where we are chosen to work with the tribal languages. Once we have this community, as a case studies, we selected two tribal languages from Karnataka and two tribal languages from Orissa. Further, one from the southern part of the state, another from the northern part of the state. Coming to the Karnataka, we have selected the Soliga language, which is a tribal language spoken by a community in Bihar Hills in Chamarajanagar districts. We have a very small population, around about, as per the source, about 40,000 population are there. Of course, most of them now bilingual in terms of talking Kannada also. But they are very proud and have a pride about this language to preserve, and will be very happy to receive language technology in direction. On the other spectrum, we have Lambani language. Of course, Lambani speakers are there throughout the state as well as the other states also, because they are nomadic people originally from Rajasthan and settled throughout the country. But from this project point of view, we are focusing on the Lambani community available in the northern part of Karnataka, and Basaveshwar Engineering College will be helping us, and they are helping us in reaching out this community and collecting the data. Coming to the Odisha, the IIT Learning is helping us with collecting the resources for the Mundari language, and Shiksha Anusandhan University is helping us for collecting the resources for Kui language of Odisha. As I mentioned, these things I have mentioned, which organization helping us with this one. Coming to the language resources creation, the first block we saw was there is no script for this language and there is no digital content. That is the bottom line from which we are starting. Then how do we plan activities for digital language resource creation? One way is you tell each group to do in their own way and get some data quickly and try to use that for developing the language technologies. Alternatively, there are a lot of brainstorming sessions happened, and we thought the pipeline that we are going to develop is not only just suitable for these 4 tribal languages. This approach should be scalable and to be replicated if someone else wants to work for the tribal languages. So accordingly, the material preparation at the first level happens in English, because that material is available in a rich manner in the public space and digital space. Then once that material gets curated and vetted by teams working on English material creation, that is passed on to another team who will translate this content from English to a major language in the neighborhood of the tribal language, which we call it as contact language. For example, for Soliga and Lambani, Kannada acts as the contact language. For Kui and Mundari, Odia acts as the contact language. So this material gets translated into this contact language. Again, there is an independent team which works. In that team also, we have 2 subgroups. One group translating, another group independently validating and vetting the correctness of the translation. After that, we pass on to another team led by all our partners, Sampurna Swaraj Foundation, IIT Learning, Shiksha Anusandhan University as well as Bagalkot, who will translate this information available in the contact language into the tribal language. And again, there are also 2 independent teams, one for first level creation, another for vetting. Once finally the information or material available in tribal language is vetted by the group, they will go ahead and collect the speech data. and they pass on all the resources created and use that resources for technology development. Of course, if you see, when I come to the text material prepared in English, which we can treat it as mostly automatic, whereas when it comes to the contact language, it is more up to call it as semi-automatic. Further, when I go to tribal language, resource creation as well as data recording, it is completely manual. So that is how the effort involved there. Of course, just to pictorially show that the common contact common point where they will meet is English, because the material starts from there. And then it gets translated into Kannada and Odia. From there, it goes to the individual tribal languages. But what is interesting is the text that we are going to prepare in English language, the same text will get translated into contact language and then to the tribal language. As a result of that, if somebody, even though we are not currently looking this group, but when this parallel corpora is available in the public domain, many researchers may be able to carve out interesting research issues and take it forward. As I told, the pipeline is, anybody wants to work on the tribal language resource creation, the pipeline that we have followed is, you get the resource first in English, vet it, then pass it on to a team working on resource creation in contact language. From there, pass it on to resource creation in tribal languages, and then go for speech data recording. I think this pipeline can be easily used by any other tribal language group to come up with the digital language resources. These are some of the pictures of our group led by Dr. Shankar Prasad sir and IIT Dharwad team, Dr. Deepak, when they went for Soliga community and gave sessions for collecting data and trained the local community to collect the data. Just as an example, I'm playing a few files, one from each of the tribal language. If you see the starting step, the text, say this sentence, I grew up near a river. That is the English sentence. This gets translated into Kannada. For example, in Kannada, we call Nanu Nadiya Bali Belede. From there, it goes into Lambani and then translated into Soliga. So in that, at least as a person, I know English, I can relate all these spoken information. There is a parallel spoken corpora also getting created. If somebody wants to work on one tribal language to the other tribal language, also can think about that in the future. For example, this is from the Lambani for the same sentence. The same sentence in Soliga. Of course, there is a lot of borrowing words in Soliga from the Kannada. And coming to Kui.
Anu jodi kututane baddi aate.
Then coming to the Mundari. So this is how the process we followed for digital language resources creation. Majority of our effort for the last 8 months or so went in that direction. As a result of this, thanks to the entire multiple teams across India, we are able to create English Kannada and English Odia parallel corpora, Kannada Soliga and Kannada Lambani parallel corpora, Odia Mundari and Odia Kui parallel corpora. Along with that, we also have few hours of speech data recorded for each of the tribal languages. So now the pipeline is well set. Now it's only augmenting this database that we have collected as much as possible. As long as the project continues, we can go on adding the resources, and any additional resource will always help us to improve the technologies. This is the effort till the resources creation. Maybe I will pause here for a minute, Chandrasekhar. Chandru, if there are any questions we can take before moving on to the spoken language technology part.
Yes, Prasanna. There are a few questions both in the Q&A box as well as in the chat box. I will try to read out a few of them that are directly related, and you could see how to address them. So from the point of view of resources, under-resourced versus adequately resourced languages, where would you place Sanskrit?
So from a digital presenter, it can be taken as high under-resourced only. It comes under under-resourced category.
So I think when you say under-resourced, mainly from a speech perspective, right? Because there are Sanskrit textbooks available.
Correct. I'm
there are
talking from a spoken language point of view. Spoken language technique.
Versus Lambani,
Yeah.
And what is the status of translation between high-resourced and under-resourced languages? Is it one of the broad goals of your project?
See, the broad goal that we have kept here is, I did not understand the question, Chandru. Translation between high.
So, I mean, is there enough technological advancement that you can translate from a low-resource language to a high-resource language and back and forth? Is that one of your objectives also?
No, so actually, the objective that we started with was from English to one of the tribal language. So we want to translate directly, but we felt that as we started discussing that direct translation is not possible, at least to begin with. We are going via this contact language. Maybe once the resources are there, maybe we can try that also.
Okay. I think that also answers another question by Mr. Krishna. What is the need for a contact language? I think the contact language is mainly used as a bridge.
Yes, that's a very, in that way, is a very important question, because the community, tribal community, may not have complete expertise in English. At the most, they have exposure to the contact language since they are in the neighborhood.
Right.
So that is where, to help them for better translation, we can transfer this from the high resource to English language to this contact language. From that contact language, they will. Initially we started direct short circuit we do, but it did not work. So they are aware of contact language, and we can leverage on that.
Okay. So there's a question about some aspects, specific language-specific aspects that might get lost due to translation. Is that a possibility that some very specific features to the language might get lost in the process of translation?
Yeah. So see, when we are talking about translation, we are trying to semantically, we want to preserve the information. But I need more clarification in terms of what is that specific language.
Yeah, I think the question is very cryptic, but let me try to extrapolate it for you. I think maybe he's talking about, for instance, you take Malayalam, there are several different variations of Ra, right? So such variations, will they be lost in the process of translation?
Okay. Now, suppose when I look for this translation, see, at the from a synthesis point of view, we are taking the resources from that target language. I think as long as that in the text that information is available, we should be able to take care of such things nowadays. It should not be.
Okay. I think it effectively boils down to whether those acoustic sounds, those acoustic waveforms are well represented in your corpora or not. Right?
Yeah, especially when we are developing the text-to-speech synthesis system,
right?
That part can be taken care. Only thing is, during the text translation, if you miss something, that will be because it can only text-to-speech it can do.
Okay. I think there's a related question on, the same language can have different variations depending on the regions or communities and style of speaking and so on. So how do you intend to capture that? I think part of it you're going to talk about in your technologies part.
As of now, and at least at this point of time, we are specifically focusing on one geographical location. For example, if I come to Lambani, there are several dialectal variations, but we are just focusing on the North Karnataka part of this one community and then collecting. Of course, then we may have to adapt them to deal with the dialectal variation, but which is not under the scope of this language, this problem. But of course, I'm sure. No,
go ahead.
Please.
Go ahead.
No, the way the technology leveraging is happening in the high resource language, this may not become a very a difficult issue to handle. We can leverage quickly on this system, fine tune it to work for the other dialects also.
I think these dialectical variations even exist even for the highly resourced languages.
Correct.
Yeah. And there's a question about detail. It's about how many hours of data do you need, for instance, for a language like Soliga?
So I will comment that in the next part of the talk.
Okay. Yeah. I think one final question, and then we will continue with your presentation. So there's a question on the source and target languages. They may vary a lot in terms of granularity and richness of content. I think the phonemic richness is what the person is probably addressing. So how can you capture the phonemic variability or phonemic richness?
In the target languages?
Target language. I mean, the phonemic, the alphabet structure in the source language and the one in the destination or target language, there may not always be a one-to-one correspondence. One may be much larger than the other. So how do you intend to, is that a challenge?
Actually, I don't think it's a serious challenge because the vocabulary and the sound unit set is unique for each language. As long as we create that mapping, we should be able to handle that. Of course, now with this deep learning models, all those things, there are many things which are even we worry about how they are working. So in that way, this finer things may not be from a technology deployment point of view, may not be a very serious concern.
Yeah. I think your main objective seems to be inclusivity. How do you make the digital content accessible, and how do you make it inclusive for these tribal languages?
Yes.
I think we have a wonderful set of questions. Let us continue with the talk, and we'll take some more questions and discussions at the end.
Okay. Thank you, Chandra. I'll continue. So, so far I presented the efforts that we are making in terms of digital language resources creation for these tribal languages. The next part of the work is, as I mentioned, we have about few thousands of parallel text corpora and a few hours of speech data collected for each of these tribal languages. Then using that, can we build some initial versions of spoken language technologies? So that is the effort that we different teams are making under this consortium. So I will briefly mention about them. Of course, one of the spoken language technology vertical that we considered was, can I build a speech-to-speech translation system, which is, as a part of National Language Translation Mission, that effort is going on for all the scheduled languages of India. We wanted to focus on the tribal language. And of course, there are two strategies there. One of the well-researched and contributed space is conventional speech-to-speech translation framework, where it will have an automatic speech recognition system, followed by a machine translation system, followed by a text-to-speech synthesis system. To begin with, we thought we will use this framework. Of course, research is also going on in how to come up with direct speech-to-speech translation, but still the technology is not matured enough to create a deployable version from there. For example, if I take this conventional framework, I take the speech from the source language, apply it to the automatic speech recognition system of the source language, which will give me the text of the source language. Then I have a parallel text created for the text of the target language. When I have the parallel corpora of source and target language, I can build a machine translation system, which can translate the text from the source language to the text in the target language. Then once I have the text in the target language, I can have a text-to-speech synthesis system, which can take this text as input and generate the speech in the target language. So we thought we will go by this conventional framework for bringing a translation system between a given source language and a target language. Here, between contact language and the tribal language, and maybe finally between English and the tribal language. So at that point of time, we focused on developing the speech recognition systems, machine translation modules, and text-to-speech synthesis for each of these languages. Okay, just to see how the initial trends come, and so where to proceed further in that regard. For this, the stack that we created was, we have the digital language resource development that is happening. Once I have the digital language resources for each of these tribal languages and the parallel corpora with the contact and the high resourced language like English, we can work on parallelly developing speech recognition system, machine translation module, and the speech synthesis system. Once I have this module, I can connect them in that conventional framework to get the speech-to-speech translation framework. Then I can use this framework for developing different applications. Like I want to translate the educational content from either contact language or English to the tribal language, or I can have a voice commerce interface. Many other applications are possible. One is once I have this speech-to-speech translation framework, then I can work on different applications. Further, I can pull out each of these modules separately, and applications also can be rigged up around each of these modules. So in that way, the parallel efforts have been started by different groups. Some groups are working on speech recognition, some on machine translation, some on speech synthesis, some on speech-to-speech translation, and some on application development itself. So that is the way the multi-prolonged effort is going on. Coming to the some initial trends on developing automatic speech recognition for Lambani language. As I told, the strategy that we decided as a part of the task force was, how do we leverage on the rich resources available in the high resourced language? So for that, suppose we have a deep learning model, acoustic model trained, wave-to-vec model, wave-to-vec 2.0 model using about 1,000 hours of speech data from different multiple spoken languages of the world. And this model has been developed by Facebook, and make it available in the open source domain where other communities can use these models, and then train speech recognition systems using them, maybe by further. So here I have to mention the effort by IITACB Foundation and also the IIT Madras team led by Professor Umesh and Professor Hema Murthy, and also AI for Bharat teams. A lot of resources are getting created for many of the Indic languages. What this IITACB team did is, they took this wave-to-vec model, which is trained for about 1,000 hours of spoken language data from other countries. And then they used about 10,000 hours of speech data taken out from these 23 Indic languages, and further tuned this wave-to-vec model to get an Indian version of this model. Now, once I have this model, I can do the fine-tuning using few hours of the tribal language speech to develop an ASR system for Lambani speech. That is what we have attempted, especially a team from IIT Dharwad built this. So what is interesting to know is the initial trends look like we don't have to go in the way of high resourced languages of collecting large amount of data. Even if we have few hours of data, we'll be able to get decent performance. Of course, as and when we get more and more digital resources, we can always improve the models. The initial trends in that direction for the speech recognition for a Lambani speech recognition system is shown here. Of course, we measure the performance of speech recognition system in terms of word error rate and the character error rate. The lower the error rate, better will be the performance of the ASR system. If you see the word error rate of what we are getting for Lambani ASR, it is comparable to many of the other languages, ASR systems that have been developed for the Indic languages. Of course, still there are some limitations of the existing system, but as an initial trend, which is very encouraging, that we can indeed cache on the resources that are available for the high resourced languages and then adapt them to work for the tribal languages. For example, this a speech file fed into this ASR system. And the recognized output is displayed here. Since Lambani do not have a script, we have used Kannada script. The decoded word sequence is same as what is spoken in the speech file that is uploaded into the ASR system. And this video briefly describes that, presents the ASR system, working of the ASR system. Sorry. We upload the WAV file to the system first. And then once this is uploaded into the system, that's what we are uploading here. And the applied to the ASR system, and the recognized system gets displayed. So this is what happens as an initial version. So then the same concept was extended to the development of machine translation system also. Here also we have the same concept where we have parent-child model concept. So we have the parent pair. For example, a large amount of parallel corpora is available between English and Kannada. So using that, you build a parent model using transformer deep learning model. And once I have that model, for example, this parallel text corpora for a parent pair, that is English and Kannada, is available in form of lakhs of pair sentences. That's a good amount of data to fine tune the weights or parameters associated with this transformer model. So using that, we develop the parent model. Once I have this parent model, then I use this child pair data, which essentially between English and Lambani, or in this current work, we have used English Lambani parallel corpora, use as a child data, and do the transfer learning on the parent model to get the child model. So now the model, machine translation model, is available for this child pair of languages, the English Lambani. And so for that, you apply now the English sentence, and the decoded corresponding Lambani sentence will be delivered by the system. For example, here in the machine translation system, we use this blue score as a measure to evaluate the performance of the machine translation system. Higher the score, better will be the performance. And for example, if I just take the parent pair, I evaluate, just use the parent model and do the machine translation between English and Kannada, I get a blue score of 14.8. Nothing needs to more emphasis. We don't need to give more attention to this number. So just as a placeholder, I'm mentioning that higher the blue score we have. Suppose if I don't adopt this transfer learning and try to build a machine translation system, just using the child pairs, where I have about 10,000 of parallel text sentences. Whereas in English Kannada parent model, we are talking in terms of 30 or 35 lakh sentences, where I have only 10,000 sentences. Of course, the model will not be trained and the blue score is negligible. Alternatively, if I take the transfer learned child model, the blue score obtained is comparable to that of the parent pair case. So here also the strategy that we had identified in the beginning, that I will make use of the resources available in the high resource language also works here as employed in speech recognition system. Here also the same strategy works where I use the rich parallel corpora available for the high resource language and then use them for building the initial versions of the model, deep learning models, and then adopt them by different strategies, including transfer learning, to get the models for the low resourced or under resourced languages. Same way, when it comes to the next module of text to speech synthesis system, here also we followed the same strategy. Of course, this is not a first time we are doing. There are published literature and attempts by many other groups in India and abroad to do that. But specifically, we are looking towards how best we can exploit this. For example, again, I use this high resource pre-trained model as a parent model, then fine tune with the low resource Lambani speech data. Specifically, the well-known speech synthesis systems employ this tachotron 2 model for spectrogram generation or time frequency representation generation of the speech signal. And that information we can pass on to a voice coder to generate the waveforms. Here also the strategy remains same, where I pre-train the model using high resource language and then fine tune it. For example, if I consider this text-to-speech synthesis system that we have developed for Lambani, the high resource language, about 25 hours of speech data from that high resource language is used for training the initial model, tachotron 2 model for the spectrogram reconstruction. And then that model is adopted by using maybe about 2.5 to 3 hours of speech data from Lambani speech to fine tune that model. Okay, so I will just play the speech signals. One, the left side I have the original speech, and the right side was the right side is the synthesizer speech.
भेसी खिचडे माई रमरीच. भेसी खिचडे माई रमरीच.
So at least when you see the quality of the speech signal, synthesizer speech, of course it is possible to improve it much better. But with that initial amount of data we have, we get a decent text-to-speech synthesis system for the Lambani language, where you can see the effort that we have spent. In a high resource language, we have collected about 25 hours of speech data, whereas for the Lambani speech, we are able to collect, as of now, we have only about 2.5 hours of speech. Using that, we are able to adopt this system and develop decent quality speech signal. Of course, objective score like perceptual evaluation of speech quality score, PES, which gives around a fairly good value, which shows that here also in this module also we can exploit the resources available and also models available in the high resource languages. So when, of course, this is a demonstration for how we were deploying the TTS system.
भेसी खिचडे माई रमरीच.
We will input the text. This is the text, Lambani text to the system.
बळन आम गाडीन मार दिनोच.
So now we can see the quality of the speech signal. So then, just to before going for the application space, I want to summarize a few points here. It has been demonstrated in all the individual modules, starting from automatic speech recognition to text-to-speech in the system, in between the machine translation also, you can see that we are able to develop these language technologies, spoken language technologies, even with minimum resources that we have collected, which gives decent performance. Of course, some points which to be highlighted here is it may not be an extensively or a robust technology in each of these verticals. It only shows the feasibility part of that. But what is important is, for example, if I go for text-to-speech synthesis of Lambani, with 2.5 hours, we are able to get that quality. Maybe another, if I collect another 2-3 hours of speech data, I should be able to get a quality which is comparable to that of what we are getting for, say, English TTS, which uses 25 hours of speech data. To that extent, we are reducing the effort for resources creation for these tribal language, because otherwise that itself will be a very time and cost intensive effort. The second part is, it is not really, I need to get the digital resources for a related language and then the models will be better trained or something. You can see that for in the ASR part, the initial wave to wave 2 model was developed by using spoken language resources from some unknown languages. Then they further trained using the Indic languages. Then further we fine-tuned for the Lambani language. So which shows that we don't really need to pay attention for, is it a related language? Can I exploit that better? Those things may be a second level, but as a technology developer, once you have this stack of high resource languages, whether they're related or unrelated, we should be able to quickly ramp them up to develop technologies for these tribal languages. So this gives us a confidence that since we have several hundreds of tribal languages in India alone, when a person sitting in Northeast region and he or she wants to develop a technology for her tribal language, when they look into the literature of what is being done for English, what is being done for Hindi or any other language, they need not be get disheartened by, oh, I need thousands of hours of speech data to build ASR system, some lakhs of parallel text corpora, or some 20 hours of speech data for text-to-speech synthesis. These initial trends indicate that even with a few hours of resources, we will be able to get a decent version of spoken language technologies for the tribal language. So that brings us a confidence that the frameworks and pipelines that we are exploring are scalable to the other tribal languages with minimum effort, and also not only for this tribal language, any other under-resourced language in abroad also can be exploit this exploration that we are making. So this is about the other part of the story, to see the initial trends of spoken language technology development for tribal languages. The next thing is there's a parallel effort in terms of, assume that I have some technology modules available for this tribal language. Can I come up with an application which requires, no, I can make use of these modules, whatever may be the level of their performance. Maybe we can do some semi-automatic approach, but rig up the application and put it for use by the community. So in that direction, one of the efforts that we have taken is the educational content translation. Yeah, of course, there are many other applications we can take up this, whatever the information available in major languages like English about various government schemes, we can translate that and make it available to the tribal community in their own language. We can work on preservation of culture and heritage, the educational content creation, which I'm going to explain in the next few slides, maybe health advisories, voice commerce interfaces, entertainment. Many of these applications can be developed and deployed for this tribal community once we have these spoken language technologies that we are attempting to do. This is a very important application. One of the partners, IIT Learning, working in Odisha, for the last few years, they are developing educational content in Odia for the benefit of rural community. again, their thought process was, if I take an educational content prepared elsewhere, there the examples they take for creating those concepts may not be reflecting the neighborhood in which the students are studying. So that is why they thought, okay, education content video prepared in abroad may not be very much gel well with the rural community of Orissa. So accordingly, what they did was they took the standardized textbook syllabus for the primary schools. Of course, now they have gone for the higher standards also, primary schools, and then they created the educational content for that. And all this effort is manual. They created the video sequences in terms of cartoon images. Then they got the voice talent, recorded the voice talent and stitched it into the video. Also, if there is any overlaid text, they manually overlaid the text to create the educational video in Odia medium. A small clip of that I will play now. This is from the IIT learning.
चटिया अन कपट खोली कहिला टुना पाखमा मुहे आस चकुली चीनी चटनी खाई चौकी ऊपरे बस चौकी कला कट कट पाखमा मु छटपट अच्छा पिले एबे हमें टुना टुनी गीतटी को पढ़िले एथिरु केतोटी प्रश्न आसुछि ताकु चल करिबा प्रथम प्रश्नटी हेउछि टुना टुनी चाउल चुना ओ बिरी बाटी कोन तयारी कले अच्छा पिला माने आमे गीत रे एबे पढ़िले जे टुना टुनी भाई भौणी दुई जण.
So, of course, they have spent a lot of time with the different teams and developed such videos starting from first standard to 10th standard now. Now they discovered another problem that, okay, this for semi-urban, urban area, Odia population, they can use this educational content. But when they went to the tribal community, again, they see a divide between knowledge transfer, because at home they speak only tribal language. So then they have to create educational content for in the tribal language also, if we want to really give credit to the language that they are speaking at home. And also, if for the students to understand, the kids to understand better, and also if they have any clarification, they can discuss at home. Otherwise, if it is in the Odia language, it may not be of much help. But they are faced with this challenge that they have spent a lot of manual effort in preparing this Odia language. Again, to replicate that effort is an among us task. That's where they were thinking that, is it possible to automatically translate this content to the tribal language? Of course, this right side video is not the finished product. It's only just a wish list, what they have given us. For example, if this is the case, I want a translated video like this in Mundari tribal language.
के चाकुली रिकाइले काजिले ओड़े लेलेम कबाड़ खोलाव के काजिले टुना कुला मामू ओ हिजुबेन चाकुली चीनी चटनी जमके चौकी चेतन रे दुबेम चौकी कटकटावले कुला मामू छटपटावले अच्छा हंको नहा आले टुना टुनी रा दुरांके पढ़ावले एनांग हेते चिमियांग प्रश्न हिजुताना दोला रिकायाबू पहला प्रश्न होयताना टुना टुनी चावली गुंडा अडु बिनी बेसाव के चिना रिकाला को अच्छा हंको आले नहा दुरांग रे पढ़ावले जे टुना टुनी हागामिसी.
Okay, so this is the problem statement they posed at IIT Learning, that if possible, if I get a translational framework to translate this education content from Odia to Mundari, if not fully automatic, at least I have a semi-automatic solution where if my effort reduces significantly, that will be a good confidence for us. Then they told we will focus more on getting a rich content in Odia, and then we can have these frameworks for translation. So then together, what is the framework that is proposed is, suppose if I have this Odia video, I'll segregate into these three important information channels we have in that. One is the video sequence, then the speech signal overlaid with the video, and the text, overlaid text that is there. So currently, of course, they, as a next level, they want to focus on making video sequence also specific to that neighborhood. But under the scope of this project, since we are only focusing on spoken language technologies, we are considering only the speech signal part and the extracted text conversion. So the proposed framework is, if I have this decoded input speech in ODR, I use a ODR speech recognition system and decode the corresponding ODR text. Maybe some manual correction and required to get the corrected output. The hope is, once I have this good ASR system in ODR, it will significantly reduce the manual effort needed for converting ODR speech to text and then the translation part. So that is where this speech recognition module knowledge will help us. Similarly, once I have the ODR text, I can use, because through this we are creating parallel text between ODR and Mundari, I can use that parallel corpora to build the machine translation system. With that, from the ODR text, I can get the Mundari text. Maybe we can do some manual correction. Here also, the machine translation system will help us to significantly reduce the manual effort. And finally, once I have the Mundari text, I can have a text-to-speech synthesis system for generating the Mundari speech. Once we have this, we can combine all these things to get back. This, for example, I have this input video in ODR. The speech channel, speech signal is extracted, and we get to pass it through the AS automatic speech recognition system of ODR to get the text decoded in ODR. From there, I have a machine translation system from ODR to Mundari. From Mundari, text-to-speech synthesis system, I generate Mundari speech. Then the image sequence, we can use it as of now as it is. And the extracted text from the video, using a machine translation system between ODR and Mundari, we can get into the text of this one and stitch all of them together to get the output video in Mundari. And this is the framework that we are attempting. So now you can see that even though the performance of each of these modules may not be up to the mark, but still they are okay as an application deployer. They are okay with that if we are able to reduce the effort by a significant amount. Later, of course, once we have enough resources, we can ramp it up to a good level. Of course, this effort is effectively from last 8 months towards resources creation, initial feasibility studies, towards developing individual technologies, and finally, a sense of application, what we can do once we have that module, so that we can make it immediately available to the community there. We need to, as a part of the future work, currently the team working towards increasing the digital language resources creation in all these 4 tribal languages, because the amount that we have collected is abysmally small. And we need to expand the speaker independent capability of this ASR system for all the tribal languages. We need to work on increasing the quality of TTS for all the 4 tribal languages. Of course, we have not yet put the speech-to-speech translation framework. Once the next thing on the task is how to plug all of them together to make a speech-to-speech translation to work from English to the tribal or contact language to the tribal. Another research effort going on across different groups in India and abroad is, how do I do direct speech-to-speech translation? Now, the issue is, if I go by the traditional pipeline, I have 3 modules. One is speech recognition, machine translation, and text-to-speech synthesis system. Each of them have their own errors. Now the error becomes cumulative when I put all of them together. In place of that, if I have a direct speech-to-speech translation from the English or contact language to the tribal language, so that will hope to reduce the effort required for developing the systems, but still it is in the exploratory stage. Of course, the framework is identified. We need to work on educational content translation system, and then the new applications development. So that is the charter we have kept for the future. And just to summarize, one of the aspects that was highlighted was the challenges involved in developing the spoken language technologies for these under-resourced languages. And another important take-home message is the significance of available technology landscape in terms of latest trends in artificial intelligence, digital resources of high-resourced languages, and also the computing infrastructure. And the initial trends in ASR, MT, and TTS module show the feasibility of and also gives confidence to this multidisciplinary team that yes, it is indeed possible to develop technologies for the tribal languages. So a small demonstration was done with reference to this, what is aimed at the educational and content translation. However, as a final remark, the big picture is here, as this multidisciplinary team, we may be working for this case studies as 4 tribal languages. We may not be able to work for all the hundreds of tribal languages that are there in India and elsewhere in the world. Instead of that, whatever the resources, approaches, pipeline framework that we are going to develop as a part of this, we will be making it available as an open resource for all the community to work. And we wish that especially the community or interested persons from the respective tribal languages will come forward, use these resources, and develop the technology and make it available to the community. I think with that, I will stop my talk here. Maybe Chandru, we can. Thank you very much.
Yeah, thank you very much, Prasanna, for a wonderful talk. It's a very exciting topic, and I think it touches several aspects related to under-resourced languages, the challenges that one encounters in handling such problems. The data is not readily available, the technologies are not readily available, but how do you make the best of the available technologies to solve such a challenging problem? I think that's very inspiring. So thank you very much. We have several questions, some at a very high level and some a bit philosophical and some very, very detailed. One question is about data collection. Was there any focus on read speech or conversational mode of data collection? Could you clarify that?
Yeah. So as of now, as a first level, we have taken the text material available in the public domain for English. So accordingly, it is more like a read speech. Maybe later when we engage with the community, we may get conversational style speech also. As of now, it is more going like a read speech.
So I think conversational speech will also be a little more challenging than read speech.
Yes.
Yeah. More variability.
Because the community, reaching them and telling them to speak something in extempore is difficult until we establish that rapport. Okay. Once we are done with first level of engagement with them, then we can ask them to narrate a story or an incident, which will become easier for them to generate a conversation. Or we can engage them in conversation and record the data. That is the plan.
I think they might also have more confidence in lending their time for data collection. Yes. Once they see some preliminary results. Okay, very nice. There's one question, it says, there are many terms for cousin in Indian languages, but there's only one term in English. So if you take English as the base language, how are you going to deal with this variability?
Oh, the text translation should take care of that, no? For example, English, depending on the context, that is the part of this machine translation part. When we are preparing the parallel corpora, depending on the semantics of the sentence, they will translate it into that one. So that effort has to be.
But to a certain extent, the ambiguity still remains,
Yeah. No, we have to live with that.
Yes.
So to some extent, but overall, higher level context when you take, to some extent, you may be able to disambiguate them. Okay. And ultimately, this is to be used by human listeners. Right. I think they will be able to. That also we can leverage.
Right. And for synthesis, do you always rely on male voices or female voices? Does it make a difference?
So, of course, what is generally the texture of female voice is found to be better. So that is where now we are building these TTS systems using the female voices, essentially because of the texture. No, we prefer that, but of course we can. There is no great preference in that way. We can also put it for male speaking.
Very interesting. I never paid attention to that part. So by default, Alexa, Siri, these are all female voices.
Correct.
Now, all the announcements in the railway stations, they're also largely
yes.
female voices. Yeah, very nice. So this is at a philosophical level. So the question says, the question reads as follows: at some stage, the kids may need to move from Mundari, the tribal language, to Odia or to English. So maybe he intends to ask, what is the life cycle of this technology, and is it really worth it?
Yeah. No, it's a very important question. See, this is what our linguistic community, they are very passionate about it, and important also, because when they talk about this endangered language, there are languages in the Northeast where only 100 people speak. If this generation migrates, that language will die. Okay.
Yeah.
But contrary, once I have this language technology, I can create the technology virtually on the digital platform. I don't expect Soliga community from Chamarajanagar to speak in Soliga. I and you want to speak in Soliga once these resources are available. So we can enhance the population. So to use that, just like we are passionate about virtual entities created on the digital world, we can make these languages available to the community. So it is it will get enhanced, further enhanced for this one. Another thing, Dr. Sriramurthy from IIT Hyderabad is working on developing this entertainment interfaces. One of the point which he is putting forward is the fact that some of the languages are preserved better because of the entertainment industry we have in that.
Right.
So he wants to put up those applications in that way. I think it is not that we will have only a small lifespan. Why should we take up? But contrary to that, what is important is we can leverage on the technological trends we have now. Earlier, a decade back, when I want to develop an ASR system, collect this, you have the text corpora word level, then you have the speech data, even phony level transcription you have to do. So many efforts were involved. Now there is nothing. You need a waveform and the word transcription. I can directly do build an ASR system. To that level, that effort also has come down. I think it's good to give that benefit to the community.
Yeah.
Of course, it is not denying the effort. No, they should not study the contact language or they should not study English. At home, the fact that they are continuing to use this language, we can make that knowledge available if it is not cost intensive.
Yes.
I
think you made a very nice point about the entertainment industry serving as a major way of keeping a language alive or even perpetuating that language or increasing the language base.
Yes.
Yeah, that's a very nice point. Yeah. I mean, we all still speak our mother tongue at homes, right?
Yes.
Homes, when we go to, when we're at a seminar or when we are in universities, we talk English, but when we are back at home, we still prefer to talk in our mother tongue. Yeah.
Yes.
Okay. So I think there's one point of information for you. There's one Mr. Dobuguntla Ramesh Bhushan. He says he has recorded about 900 sentences for a nomadic community language called Dungri Garasia, followed by 3 token recording. So this is some information for you. There is the existence of such a recorded database. So maybe you can leverage that. Yeah.
Definitely.
Yeah, perhaps Mr. Dobuguntla, you could get in touch with Professor Prasanna.
Yeah, kindly.
Yeah. There's also a question about choice of English as a base language, particularly when everybody seems to believe world over that Sanskrit is more structured, and why did you not choose Sanskrit as a base language for NLP?
No, it is purely based on the multi-disciplinary team we had. Most of us were, to begin with, comfortable with English, and the resources available in English. As I told, the landscape that we are starting is we have a lot of digital resources available in that language. and also deep learning models available in the public domain. We wanted to cash on them and take it to the next level.
I think the technology has matured for English, and you want to leverage that when you build technologies for a new language under resourced. I had a couple of questions myself. So do these languages, do speakers of this language also do code switching?
Yeah, that's definitely they do code switching, because for example, when I was communicating with Lambani speakers, of course, they speak few words in Lambani, few words in English, few words in Kannada, because when they come out of their home at the public place, they speak in Kannada.
Okay.
And office, they speak in English, and at home, they speak in Lambani. The code switching is a very natural phenomenon.
Okay, so they switch between Kannada,
at least bilingual, the tribal language and the contact language.
Okay, okay. And this contact language, because the Lambanis are a nomadic tribe, they have traversed over several parts of the country. So the contact language itself might be different depending on which regional community you're addressing, right?
Definitely, definitely. So, for example, we have this Lambani population in Telangana and Andhra also.
Right.
They have borrowed, since they have settled there for centuries, they have borrowed a lot of resources from Telugu. So there we may strategy has to be slightly different compared to, of course, we can use this pipeline. Maybe we may have to do some fine tuning.
Yeah, some adaptation or domain adaptation, or maybe transfer learning kind of.
Yes.
Okay. Is there also some kind of a language graph structure to say which two languages are closer to one another than, how languages are connected? Is there some kind of a graph structure like that for languages?
Yeah. No, actually, that slide I did not put, because this, especially these language families that we have. For example, even though I just classify it as a specific tribal language, but in a bigger language family like Indo-Aryan, Dravidian, like that. So we can group them under that broad language families. Then we can look in that direction also, how to leverage on those languages.
Okay.
These things are available by the linguistic community.
By the linguistic community.
Yeah.
Okay. I mean, I have several other questions, but I'm afraid the time is running out, and I'm sure your contacts are available to anybody who would like to reach out to you and ask questions. So let me thank you for a wonderful talk, and I will now hand over the stage to Dr. Sushila.
Thank you.
Thank you very much. This evening, we've had yet another wonderful webinar. All the more exciting because this was a project that Professor Prasanna and in the AI task force, when we discussed it and brainstormed about it, we were just so excited because this was about addressing a challenge of people being integrated, inclusion, and of communities that otherwise would not be commercially viable, financially viable, if you were to look at it from that point of view. So that was a challenge we felt that was worthy of being taken up by an organization such as ours. So I'm really delighted that we've been able to bring something up and showcase it to the world. So I want to start by, of course, congratulating Professor Prasanna for having led so wonderfully. So just kind of quickly wrapping up. The World Bank has said that indigenous people own, occupy, or use 25% of the world's surface area, but they safeguard 80% of the world's remaining biodiversity. Given how rapidly all of us are pushing the world to the brink of a completely irreversible disaster, it becomes very, very important to preserve and promote traditional knowledge systems, even more in our current context. The IIT Dharwad logo says, Sa Vidya Ya Vimukte, that is, the knowledge that liberates is knowledge, that which liberates is knowledge. And really speaking, that is what these traditional knowledge systems have done for us through the millennia. And of course, you need language to be able to codify, document, and communicate, learn, preserve all of this knowledge. Of the 7,000 spoken languages, very few. So this particular project that was taken up is an open source project. And that again is something we're very proud about because we hope that on this, a lot more can be built over time. We've all really enjoyed and continue to enjoy working in this consortium, IITACB, IIT Dharwad, and all the other organizations that Professor Prasanna talked about. And just a few points, the strategy adopted really looked at how it is done in high-resource languages, how those tools, what were the tools, and then applied the same ideas, but there were a few adaptations such as looking at parallelizing a lot of the work. Data is clearly a challenge, especially with a language that has no script. And standard methods would require a lot of data. But these small Indian tribal languages with a handful, like our Soliga is spoken by about 40,000 people. That's not a whole lot of opportunity to even be able to generate data. So despite our rich multilingualism in India, despite that, it is really hard to generate tons of data. So the really nice way in which this project has handled that is by saying we use the EGSTEP data. Again, fantastic work that's been done by EGSTEP, but using 10,000 or more hours of speech in a variety of Indian languages, 23 Indic languages, and then building on top of that, which a very small number of hours of spoken data, speech data in the chosen tribal languages. This is a method that has been used to really ramp up and be able to run this project without agonizing over generating data. The other very nice thing has been, it is not just about data, speech, etc. It's about reaching into communities in the multidisciplinary teams, working with NGOs and other organizations like Sampurn Swaraj Foundation or Aveti Learning. And then the various methodologies, such as how the project has actually been executed, the framework that's been adopted, shifting from a conventional framework, which is sequential, to having several teams working in parallel, and now looking at applications that will build on top of all of this speech work. Clearly, there's a lot more work to be done, but we are really excited and hope to continue not just this one collaboration, but we hope that we can pick up together with our audience and our various partners. We hope we can pick up many other important issues, impactful issues, and really be able to bring these inter-IIT, the IIT alumni network, the corporate world, as well as the academic world, and be able to enable these collaborations, consortia to work together to solve these big issues. So we look forward to hearing from anyone who would like to come up with an issue. We'd be happy to hear, listen to you, work with partnership with us, as well as for today's lovely presentation. Many thanks to our audience for being here, for participating. Your questions make it very lively, and it's important for us to hear from you as well. Please, in a couple of weeks' time, we're going to have our next webinar. Please do continue to participate and be here with us. And with that, thank you once again. Goodbye.
Thank you, Sushilaji. Thank you, Chandru. Thank you, Professor Narayan.
Thank you, Professor Prasanna, Professor Narayan, and Dr. Sushila and IITACB. Yeah, thank you.
Thank you. Goodbye.
Thank you.